Right, implicit differentiation. Let's look at the basics of it. Right, now implicit differentiation, you need to use that method when you have an implicit function. What we mean by an implicit function is y isn't actually given in terms of x. Okay, we haven't got a straightforward function such as y equals f of x. So you have y equals and loads of things in terms of x. Here, it can't be written like that, right? So it's an implicit function rather than an explicit function, which is what this would be called. Now, when you differentiate it, you want to differentiate with respect to x, okay? And you need to realize that ultimately what we're doing is we need to differentiate each part of it with respect to x, okay? Okay? So each part of it we need to differentiate with respect to x. Now this bit here is easy, because if you differentiate this with respect to x, you just get 3, don't you? This bit is not so straightforward, because you want to differentiate with respect to x, but it's a y function. And you can't differentiate a y function with respect to a different letter. So what we do a little trick. We will differentiate it with respect to y, okay? Because that's the only way you can differentiate it. Because it is a y function, you can only differentiate it with respect to y. But if we put a dy dx on the end, times it by a dy dx, using the chain rule idea, okay, then we haven't actually done anything wrong. Because if you think about it, it's like the dy's will cancel, yeah, because you've got a dy on the top, dy on the bottom, as if they cancel. And you actually, what you're doing then is differentiating with respect to x, because if that goes with that, you're left with d by dx. Okay, so it's like differentiating with respect to x then. It's exactly the same as that, same principle. But of course, what we'll end up doing is differentiating with respect to y, and then putting a times it by dy dx at the end. Okay, now here d by dx of 3x is just 3, okay, because you can differentiate that with respect to x. Here again, it's a y function, so you can't do that. So you're going to do d by dy, okay, of y. But of course, to sort of make it right, you put a times it by dy by dx on the end, like the dy's cancel, so you're left with that, all right? And then over here, then d by dx of this, well, 3 is a constant, so that'll be 0. Pi squared, well, pi squared is also a constant, isn't it? Because pi is just 3.14. If you square it, it makes it bigger, but it's still a number. So when you differentiate a constant, you get 0, okay? So d by dy of y squared is 2y, all right? And then make sure you times it by dy dx, all right? Plus 3 plus d by dy of y is 1, isn't it? Differentiate y with respect to y, you just get 1 times dy dx equals 0. What you do then is you factorize the dy dx, okay? So you put 2y plus 1, okay? Because dy by dx is a common factor of both of them, all right? So you factorize out the dy dx, you've got 2y plus 1. Take the 3 over the other side, so it equals minus 3. And then to get dy dx, you do minus 3 over then the 2y plus 1. Okay? And we've got our answer. Now, in practice, in the exam, you wouldn't have to write all of this, right? To start, you wouldn't need to do that. Quite simply, right? If you've got the question, I'll redo the question. But in the exam, you don't need to write d by dx of y squared, right? You just go with it naturally. What I tend to do is I tend to say, look, differentiate with respect to x, okay? So I differentiate that. Of course, I differentiate with respect to y first, but then I've got to make sure I put a dy dx in the end. 3x becomes 3. Y will differentiate with respect to y, which is 1, but I've got to put a dy dx in the end, and that equals 0. So then you're left exactly with the same scenario as before, okay? And you get your answer then. Okay? Get your answer just as we had at the top there. If we look at a C3 type question, right? Find dy dx. Well, x to the power 4, we can differentiate this now with respect to x. X to the power 4 becomes 4, bring the power down. 4x, reduce that by 1, 4x cubed. Sine y, well, it's a function of y, so differentiated with respect to y, you get cos y, of course. But don't forget to put a dy dx on the end. Now this here, notice here we've got a product, and a product usually appears, okay, in C3. This is a product. So in order to do product, right, we need to sort of do it by the side over here. So that's what I tend to do. I tend to do this separately over here. So you've got x squared y cubed. So the product will set u to equal x squared, v to equal y cubed. Okay, the first function is x squared, second function is y cubed. So du dx is 2x, and then dv dx. So you differentiate this with respect to x. Of course you can't, so differentiate with respect to y first. Be 3y squared, but don't forget to put a dy dx on the end, okay? Then the product rule, crisscross v du dx, which is 2xy cubed, plus then that times that, so that'll be 3y squared dy dx times that, so that'll be 3x squared y squared dy dx. So now we've differentiated this, okay? So basically d by dx of all of that becomes this, alright? So we can, because I'm differentiating this now with respect to x, this now has been done over here. So I can just plonk that in, plus 2x y cubed plus 3x squared y squared dy dx. Okay, just squeeze that in there. And of course then equals to 9. Differentiate that with respect to x, I get 0, don't I? So make sure you put 0 there. Okay, all you've got to do then underneath is factorize out the dy dx. So cos y plus 3x squared y squared. I've got dy dx attached to them. So factorize that out. Take the other stuff over the other side. So I have minus 4x cubed minus 2xy cubed. Then dy dx will equal minus 4x cubed minus 2xy cubed. All over them, because we times them by dy dx. Take it over and divide. Cos y plus 3x squared y squared. Okay, just to finish off, we could factorize the top here, just to make it a bit tidier. We could take out a minus, because minus goes into both. Chuck the minus in the front if you want, be better. But we could also take out 2, couldn't we? 2 is a factor. We could also take out x as a factor. So we have x, 2x, isn't it? Squared, yeah? I've got to times 2x by 2x squared to get that. Take away then y cubed, okay? To get the 2x y cubed. Okay, and I say take away, my mistake there, because I'm putting the minus in the front. Of course, that minus 2x then, to multiply something here to get minus 2xy cubed, that needs to be a plus, doesn't it? Okay, so if you take that minus 2x through, you'll get what we've got on the top. Cos y then plus 3x squared y squared.